Welcome to this segment of in-dealership training. Today we'll take a look at the Bosch Motronic M2.9 engine management system that's used with the VR-6 engine offered in the Corrado and Passat. The Motronic system features sequential port fuel injection, cylinder selective knock regulation, a single ECU to control all fuel and ignition requirements, and a permanent fault memory and self-diagnosis accessible with the VAG 1551. What we'll cover today is a system overview, component location and operation, and using the 1551 to check the Motronic system. The Motronic Engine Management System is similar to other fuel injection systems that you're familiar with. Various sensors monitor the running of the engine and send their signals to a central processing ECU. The ECU evaluates these input signals and generates output signals to various actuating components. Let's take a look at these input and output components. The Hall sender is located in the ignition distributor. It acts like an electronic control switch. The Hall signal is used with the engine speed reference sensor to identify cylinder number 1 for sequential fuel injection and knock regulation. A hot wire air mass sensor is used to measure the airflow into the engine. The air mass sensor is attached to the air filter housing. The sensor housing includes a baffle grid which reduces air turbulence and pulses. The sensor has no moving parts. A thin, electrically heated platinum hot wire in the sensor is kept 180 degrees centigrade above the air temperature measured by the thin layer platinum temperature sensor. As airflow increases, the wires are cooled and the resistance of the sensors changes. Current to the platinum hot wire changes to maintain the constant temperature difference. The resulting current change is converted to a voltage signal and is used by the Motronic ECU to calculate the volume of air taken in. Dirt or other contamination on the platinum wire can cause inaccurate output signals. Because of this, the platinum wire is heated to 1000 degrees centigrade for a period of 1 second each time the engine is switched off to burn off this dirt or contamination. That's why it's very important not to disconnect or remove the air mass sensor or Motronic ECU for at least 20 seconds after switching the ignition off. Engine speed and crankshaft position are measured by a single sensor located on the engine block. The sensor reads a toothed wheel mounted on the crankshaft to read engine speed. The toothed wheel has a two-tooth gap which is used as a measuring point for top dead center of cylinder number 1. The throttle valve potentiometer is connected to the throttle valve shaft. It informs the Motronic ECU about power requested by the driver. In addition to these load requirements, the throttle valve potentiometer signal helps determine the start of idle speed stabilization, full load enrichment, and deceleration fuel shutoff. If the throttle valve potentiometer fails, the Motronic ECU uses the signals from the engine speed reference sensor as replacement signals. 2 knock sensors are used by the VR-6 engine. One sensor for cylinders 4, 5, and 6, and one knock sensor for cylinders 1, 2, and 3. The knock limit varies from cylinder to cylinder and varies within the operating range of the engine. Therefore, knock regulation is done cylinder selectively. The ignition angle of the knocking cylinder is retarded in steps until the knocking stops, up to a maximum of 15 degrees. If knock is still detected, the ECU will retard the ignition timing 11 degrees for all cylinders and record a fault in the fault memory. An oxygen sensor is mounted in the exhaust manifold. The outer platinum surface is exposed to the exhaust gas, while the inner surface is exposed to the outside air. An engine coolant temperature sensor is mounted in the thermostat housing. The engine coolant temperature sensor is an NTC resistor. As engine temperature decreases, the resistance of the sensor goes up. The signal from this sensor acts as a correction factor for determination of ignition timing, injection timing, and idle speed stabilization. In addition, these systems are activated depending on the signal measured by the coolant temperature sensor. Knock control, adaptation of idle speed volume, oxygen sensor operation, fuel tank venting, and exhaust gas recirculation. A stored value of 80 degrees centigrade, 176 degrees Fahrenheit, is used by the ECU in case of a faulty coolant temperature sensor signal. An intake air temperature sensor measures the temperature of the air in the intake manifold runners. This signal is used as a correction factor for the intake air temperature measured by the air mass sensor. It's also used for idle stabilization and as a correction factor for ignition timing. So, we've taken a look at all the input components for the Motronic system. Let's take a look at the Motronic ECU and output components. A 68-pin electronic control unit located in the plenum processes all the various input signals and sends output signals to the actuators. The control unit regulates all fuel injection and ignition functions of the Motronic system. It also has a permanent fault memory and self-diagnosis feature. The Motronic ECU sends a signal to the fuel pump relay on the fuse relay panel, which in turn activates the two-stage tank-mounted fuel pump. At the same time, it also sends a signal to the oxygen sensor heater relay. Another signal is sent to the idle stabilizer valve, which regulates idle speed. A new feature with this idle stabilizer is a sound dampener. If the output signal to the idle stabilizer valve is interrupted, the valve will open to a fixed position, which is equivalent to a warm idle speed. Fuel tank vapors are vented via the carbon canister and carbon canister frequency valve. The frequency valve is operated by a duty cycle signal from the Motronic ECU. It's located here on the right front shock tower underneath the air mass sensor. The valve operation is load and speed dependent during driving operation. The valve is completely open at full throttle and completely closed during deceleration fuel shutoff and idle. A spring-operated check valve inside the frequency valve closes when the engine is off. This prevents fuel vapors from entering the intake manifold and causing a rich mixture on restart. Sequential fuel injection by the solenoid-type fuel injectors is also controlled by a ground signal from the Motronic ECU. Four-hole injectors are used to provide uniform spray patterns and help prevent deposits from forming on injector tips. The injector quantity is determined by the injector opening time. This can be seen on the VAG 1551 during self-diagnosis. Ignition output for the Motronic system is controlled by the Motronic ECU. Input signals from the engine speed reference sender, air mass sensor, knock sensors, throttle valve potentiometer, coolant temperature sensor, and hall sender help the ECU determine engine speed, engine load, knock regulation, coolant temperature, and sends an output signal to the ignition coil power stage to fire the coil. So, there we have it. Let's review for a minute. Various sensors monitor the running of the engine and send their signals to a central processing ECU. The ECU evaluates these input signals and generates output signals to various actuating components. We've covered a lot of ground so far. You can find more information about the Motronic Engine Management System and the VR-6 engine in the self-study program number 402. the new Volkswagen VR-6 engine with Motronic Engine Management System. The M2.9 Motronic Engine Management System has self-diagnostic capabilities accessible with the VAG 1551. Let's look at what it can do and what is different from what you've seen before. With the 1551, you can check the following functions. 01, check control unit versions. 02, check fault memory. 03, output check diagnosis. 04, introduction of basic setting. 05, erase fault memory. 06, end output. And 08, read measuring value block. What we'll look at now are function 3, function 4, and function 8. We're not going to give you a lot of details about all the data you can find, but rather show you some of the Motronic 1551 capabilities. We're really only scratching the surface. When you select Output Check Diagnosis, what happens is that the 1551 directs the Motronic ECU to test the electrical function of the output components of the fuel injection system. You might be familiar with this from testing the CIS-E Motronic found on the 2-liter 16-valve motors. These are the components you can check with the output check diagnosis on the Motronic system. Fuel injectors, idle stabilizer, carbon canister frequency valve, the oxygen sensor heater relay, and the EGR frequency valve if equipped. What's important to remember for the output checks of the Motronic system is that you need to connect an LED test light to the injector connector. That's because you can't hear the injector click during operation. After selecting Output Check Diagnosis, connect the LED test light to the injector connector and then open the throttle. The LED will flash 5 times. To test the next injector, you'd open the throttle valve again. To test any injectors beside the injector for cylinder number 1, you'll have to remove the upper half of the intake manifold. Remember, this test will only tell you if you have current to the injector. It won't tell you if it's working mechanically. One last thing to remember about output checks is that you may get a display on the 1551 for a component that's not on the car. On this car, you'll get a display for intake manifold changeover valve, but the vehicle doesn't have one. If you do get a display for a component not on the car, just ignore it and continue with the other tests. Next, let's look at function 04, Introduction to Basic Setting, and select Display Group 00. As you can see, we still have the 10 channels of information that you're familiar with, but we no longer need this because the information is given in actual values in other display groups. Let's see what's available if you select Display 01. Here you have 4 channels that display actual values. For example, this channel is the lambda factor. It represents the voltage from the oxygen sensor. A 1 in this position would mean that the air-fuel ratio is 14.7 to 1. A number less than 1 would mean a rich mixture, while a number over 1 would mean the mixture is lean. If we create an air leak in the system, you can watch the lambda factor change. The other channels in this display group are for engine RPM, engine temperature, and the last channel here is for ignition timing. There are also 6 display groups in function 08 available. If you select display group 02, you'll see some more actual values. For example, this is the fuel injection opening duration measured in milliseconds. If you open the throttle, you can see the opening duration increase. These other values are for engine RPM, supply voltage, and the temperature of the exhaust gas being recirculated. You'll have to check the repair manual microfiche for a description of all the information displayed. Display Group 04 has some information that's pretty unique and something you may not be familiar with. If you look in Channel 4, you will see a series of zeros. They represent switched inputs to the Motronic ECU. This zero represents deceleration fuel shutoff. If a 1 is shown, it would mean that the potentiometer is sending the Motronic ECU a signal to begin deceleration fuel shutoff. This number represents engine idle or throttle closed. Once again, a 1 here indicates a closed throttle. If we open the throttle and come off idle, the number will change to 0. Again, you can check the repair manual microfiche to see the meaning of all these switched inputs. We've been using program card level 3 for the 1551. You should be getting this card very soon if you don't have it by now. You can tell if you have program card level 3 by the number on the corner of the card here. If you don't have the program card, you may not be able to get all the displays you've seen here. You probably noticed that some of our displays are written in German. That's because we're using a German program card. Don't worry, your card will be in English and have all the same functions. One final thing we should look at that's related to using the 1551 is road testing a vehicle. You should always do a quality check of your repair to make sure you've corrected the problem you've been working on. During the road test, drive the vehicle at least 10 minutes and make sure the engine coolant temperature reaches 80 degrees centigrade and 176 degrees Fahrenheit for at least 3 minutes during the drive. With the transmission in 4th gear at a vehicle speed of 30 miles per hour, accelerate 1/2 throttle for at least 4 seconds. Next, briefly accelerate to full throttle. What we're doing is providing the Motronic ECU with enough operating information to register a fault if one exists. After the road test, see if the Motronic ECU has trapped any faults by checking it with the 1551. Well, that about does it. Let's take a look at what we've covered in this tape. We looked at the operating principles of the Motronic system, and we looked at what you can do with the 1551. And finally, we gave you a tip about road testing after using the 1551. Thanks for watching.